Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about one more example of the binomial distribution. And this is the previous examination question. The example is, if the mean and variance of the binomial distribution are 6 and 1.5 respectively, find expectation of x minus p of x greater than or equal to 3. So now coming to the solution, given that here the random variable x is the binomial random variable. The mean value of the binomial distributed random variable is NP, that is NP is equal to 6 from the given data, and variance of the binomial random variable is NPQ. From the given data, the variance is NPQ is equal to 1.5. Substitute this NP value into this equation. Q is equal to 1.5 by 6, which is equal to 0.25. We know that P plus Q is equal to 1. From this equation, P is equal to 1 minus Q. Substitute Q is equal to 0.25 into this equation. We get P is equal to 0.75. So therefore, now substitute P value and Q value into this equation. N is equal to 1.5 divided by PQ. So P is equal to 0.75, Q is equal to 0.25. Substitute that values into here. We get N is equal to 8. So therefore, N is equal to 8, P is equal to 0.75, Q is equal to 0.8. Now here from the given data, we can determine expectation of x minus p of x greater than or equal to x. Using expectation property, expected value of this one is equal to expectation of x minus p of x greater than or equal to 3. So expectation of x is the mean value of the random variable. From the given data, the mean value of the random variable NP is equal to 6, and using binomial expansion, P of x is equal to x is NCx into P power x Q power n minus x. And first calculate P of x greater than or equal to 3. So using one of the property of the probability density function, P of x greater than or equal to 3 is 1 minus P of x less than 3. So P of x less than 3 means the values of the x are x is equal to 0, x is equal to 1 and x is equal to 2. So that is 1 minus P of x is equal to 0 plus P of x is equal to 1 plus P of x is equal to 2. Now here n is 8, P is 0.75, Q is 0.25, and calculate P of x is equal to 0 value using this expression. Calculate P of x is equal to 1 and P of x is equal to 2 using this expression. So first separately calculate x is equal to 0, P of x is equal to 0, substitute x is equal to 0, we get 8C0 into 0.75 whole to the power of 0, 0.25 whole to the power of 8. And reducing this RHS term, we get that value is 0.00015. Next, P of x is equal to 1. P of x is equal to 1 is 8C1 into 0.75 whole to the power of 1, 0.25 whole to the power of 7. Simplifying this RHS term, we get the value is 0.00036. Next, P of x is equal to 2. P of x is equal to 2 is 8C2 into 0.75 whole square into 0.25 whole to the power of 6. So 8C2 is 8 factorial by 2 minus 8 minus 2 factorial into 2 factorial into 0.75 whole square into 0.25 whole to the power of 6. Reducing RHS term, we get 0.0038, and substitute all these values into this equation. We get P of x greater than or equal to 3 is 1 minus P of x is equal to 0 value, and this is P of x is equal to 1 value, this is x is equal to 2 value. And simplifying this RHS term, we get P of x greater than or equal to 3 is 0.9957.